content. I wanted the video so I could have you guys go back and look at content, and I also have a record of it too. I'm going to be looking for things like not just, this is how you do it. You do this and you do that, but that you also say why it's working, okay? So the conceptual ideas behind it. So that's what I'm going to be looking for. The rest of it is sort of a rubric like what they used to grade base 397 on. Now I think they got a little different one, but it's pretty close to it. So that's the presentation part. So Amy, you need a pen too, don't you?
Why?
Because you're going to.
Oh, I'm grading y'all? Oh, these are for y'all.
Yeah, you grade 2, and they grade 2, and Amy looks at 3, and I look at 3.
Okay, what am I doing?
Mark zeros all the way across.
Ever who the presenter is, and then just what you think. Out of a score of 25, what do they get and stuff like that.
Oh, you guys had
Remember,
better
we're
be
related.
good because you know
We're
You're-
related.
you're speaking to somebody who does not speak your language, so you're going to have to be very clear.
So this is just strictly on presentation, so that's why I thought it should be good. I'm going to be looking more at content.
Yeah, I'm going first.
And Emily, were you 3? You're 2. Lauren goes next.
Oh, I go last?
Mm-hmm.
No.
Oh, I thought you were 2.
Yeah, I
Sorry.
thought you were too long, too.
Person 3 went up. What? Okay. You numbered up. Who was 1?
She did
Matt?
it
Matt?
on the calculator.
And you're 3?
Yeah, Emily's
Okay. All right. So the number came up 1, and then 3.
Okay, gotcha. Oh, okay. Fatal. Right now. I failed you.
Following you around the room.
Look at my materials. Camera, flip video, or camcorder, tripod, rubric, and Amy.
Oh, I'm so honored. I feel so special today.
Oh, you do. Okay, I see.
Can I go home after this class? I will have done a whole day after this.
Ready?
I'm ready. You ready?
Maybe. We'll
No.
see. I haven't read the article yet, so.
He's just kidding.
I'm joking. I'm joking. Okay. Today, class, we'll be learning about the substitution method, which is a way of factoring trinomials, which we've been talking about in the last few class periods. Okay. So, what are kind of like the ways that we well, why are we talking about this? Okay, so students seem to have trouble factoring with a non-zero leading coefficient. So what that means is they're good at this right here, x squared plus dx plus e, trinomials of that form where there's no coefficient or the coefficient is 1. And so we're going to talk about how we can get this ax squared plus bx plus c where there's a non-zero or a non-1, I guess, leading coefficient, something other than 1, to look like this. And that's what the substitution method is about. We're going to get a perfect square at the front of the trinomial. So how are we going to do that? Let's talk about that. So as going through it, the substitution method is going to rely on some prior knowledge. And these are some key vocabulary terms that you're going to need to know about. Class, do you have any problems with these vocabulary words? We've got factor. What is a factor? What is your greatest common factor? Multiplication by form of 1. We're going to do some distributing using the commutative property and the multiplicative identity. Are y'all good with those? Good with those? All right, great. So, I figured a good way to teach this method would be to just use an example, and we'll go through it and see what y'all think about it. So we're going to use this this trinomial right here as our example. 15x squared minus 12x minus 3. And we're going to use the substitution method. All right. So remember we talked about we want to get a perfect square right here on this very first term of our trinomial. So does anyone know how we might go about getting a perfect square right here? Does anyone have any ideas? Class? just spitballing ideas. No, okay. So we have x squared, so we probably won't need to do anything with the x. But 15 we know is not a perfect square. So how are we going to get it to be a perfect square?
You're gonna add
We're gonna add what?
1.
We're gonna add 1.
1x squared. Because
No, we've already got the x squared. We just want to make this a perfect square. So how about we multiply that by 15? Yeah. Okay. So let's do that.
that's it.
All right. So like I said, here we go. We're gonna add 15. That doesn't look good. Okay. So our problem was 15x squared. What is it?
12x.
Minus 12x minus 3. Okay. 15x squared minus 12x minus 3. So we want to square this 15 right here. So let's do that. Let's multiply this whole thing by 15. Now remember I mentioned multiplication by a form of 1. So we can't just multiply this by 15, that changes the whole problem. So what are we going to have to do to undo this 15 right here?
Divide.
Divide by 15 as well. Perfect. So we get something that looks like that. Do we all agree that this is the same equation as the one we had before, the same expression as the one we had before? Good. Okay. So now we talked about distributing. So let's go ahead and distribute that out. So we're going to multiply this 15 by each one of these terms in our trinomial. That's going to look like this. Right? Do we all agree with that?
Yes.
Yeah? Okay, cool. So now comes the substitution part of the substitution method. If you look right here, what do we have in parentheses? We have a 15x. We have another 15x. So let's go ahead and we'll assign a variable to 15x to kind of hold its place, but give us something more simple so that we can kind of look at it as a trinomial that we've kind of been used to factoring. Okay, so let's say over here off to the side, 15x equals c. Is that okay with everyone?
Yes.
Okay, great. So if we rewrite this, we'll have what?
C squared minus 12z minus 45 all over 15.
Sweet. That works for me. Okay. Let's get a new page. So we have z squared minus 12z minus 45 all over 15. So now, like I said, we have a trinomial up here that's of the form x squared or z squared minus dz minus e, where d and e are coefficients, and then we don't have a coefficient right here. It's 1. So we can factor that. Does anyone want to factor it? I'm gonna take a second to write it out, or I can tell you. Let's tell you. Okay, so we have z and z. Factors of 45, that'll give us a negative 12.
15 and
15 and 3. Negative, so we want to subtract 15 and add 3. Does everyone agree with that?
Explain that. I don't understand why you made the 15 a negative.
Okay. So we know that we need factors of 45 to go here and here. Do you agree with that? Because when we're FOILing, our last term is these two numbers right here, and that's going to give us this.
Okay.
Okay?
Why is
Okay, when we're multiplying binomials, such as these, this is the method that we use. So if you look, you've got z and z, gives us z squared. This is outside, that gives us z, and this value right here, which
So
is,
You're multiplying.
So are you basically distributing?
yeah, you want to distribute this throughout, and then we're going to distribute this throughout.
Okay, that makes sense.
Yeah. And then
I
We can
see.
simplify-
Negative 15 plus 3 is
we can
negative
simplify,
12.
yeah.
Okay.
Yeah, okay. So we all agree with that. That's good. There we go. Cool. Oop, that's not my eraser. That is. There we go. Okay. So this is the same thing as this. We agree with that?
Yes, sir.
Cool.
Except
We don't want to drop the
Yeah.
denominator though. Let's keep that thing.
that's important.
Yeah. Okay, so we had earlier that, what was it? That
15x
15x equals
z.
z. Yeah, that works for me. So let's bring this back in. We'll take our z's where we see a z, and we're going to substitute it with a 15x. So let's do that. 15x minus 15. Got that? 15x plus 3. Got that? And once again, let's hold on to that denominator. Okay. Now what do you see that we might be able to do here and here? Any ideas?
There's a
Take out
greatest
the-
common factor.
There's a greatest common factor. Sweet. Perfect. So let's take it out. What is the greatest common factor in this term right here?
15.
15. Okay. What do we have left?
An x.
Negative 1.
And a negative 1. Does that look good to everyone? That matches? Cool. What about this one? What is our greatest common factor in there?
A 3.
A 3. And what do we have left?
A 5x plus 1
5x plus 1.
divided by.
Alright, remember how we, at the beginning, we multiplied by what, a form of 1? So, do we all see that we've got another form of 1 right here?
Yes.
Which
so-
is, okay, so 1 is what? It's the, what kind of identity? Multiplicative. Multiplicative identity. So when we multiply by 1, we're staying the same, right? We all agree with that?
Yes.
So let's go ahead and get rid of those 15s.
All right.
Can we do that?
Mm-hmm.
Okay. So we've got x minus 1, 3, and 5x plus 1. Those are going to be cool. Now this 3, I don't like that 3 there. So we've got a unique rule in multiplication where we can commute our terms. So is everyone okay if I do this? Is that going to stay the same? All we're doing is we're bringing this this term that we're multiplying by, taking it to the front. That's called the commutative property of multiplication. I think y'all have learned about that before. And just to clean this up, we can go ahead and distribute that in. I think that looks better. Distribute this 3 into this term right here, and this will stay the same. Multiply a 3 by an x, we get a 3x. Multiply a 3 by a negative 1, we get a minus 3. We cool with that? And then, so that right there is factoring the original trinomial that we had.
So if we checked our work, would we get the same original?
That is a great question. 15x squared minus 12x minus 3 is what we want. So help me multiply this out.
You're gonna take the 3x and multiply it to the 5x, and that's 15x squared.
Okay.
And then you're gonna take the 3x again and go to the 1. So 3x times 1 is 3x, so plus 3x. Then you're gonna look at your negative 3, and you're going to do negative 3 times 5x, which is negative 15x. And negative 3 times 1 is negative 3. And then...
We have like terms right here, right?
So you put them together.
So we've got, what is this gonna turn out to be?
Negative 12x. Yay!
And it matches. So what we've done is we took out that leading coefficient, we substituted in something that we knew how to factor, and then we factored it out, brought it back in, and we were able to get this. And that's the substitution method. Do you have any questions about that? Yes, ma'am.
Which one is my final answer up there?
Well, we were talking about factoring. So this right here gives you the two factors of this, which is what we were setting out to factor. So
Okay,
this is
well-
the final answer that I'm looking for.
Okay, connect back to arithmetic, all right? When you factor natural numbers, what do you factor them into?
Primes?
Primes. Is that prime? That's your final answer. The other one is not.
All right, everyone, that's your final answer. The other one is not.
One of your students had to tell you that. I have seen somebody do this in a presentation out at Region 14, and I mean, the Algebra 2 teachers came unglued, and I never got to see her presentation. She wouldn't give it to me before she went. And she factored all the stuff like you did at the end, and they were coming unglued because it's not factored into primes. There is still a greatest common factor between 3x and negative 3 in that last one.
So we couldn't use it.
So that's when you can't use it. It is not prime, it's not factored into prime polynomials. All of those are linear. The other one actually is a constant, the 3.
Mhm.
So it's prime. Even if it was 45, it'd still be prime as far as a polynomial.
So I have a question.
All right, quick question and then we'll go.
Okay. What happens if I forget to substitute back in the 5x, 15x? Is it just not, it's not right?
I mean, you're changing the variables. You want to keep the variables the same throughout. So we started with an x squared. So we need to have x's in our final answer. So my recommendation would be, don't forget to do it.
Do you think it would be common for students to forget to?
Not with the substitution. I mean, that's the whole point of it, is to bring in the new variable and then take out that new variable and put in the old
Really
one.
factor, you didn't plug it back in, right?
Done.
Snaps from that. I can't really snap. Yay!
Now, it's kind of interesting. Matt approached this presentation as if he was teaching Algebra 2 students. Many times people will approach it as if they are giving a talk at a conference. And in Math 397, 497, it's going to be conference.
Jeez.
Okay, y'all have any other things for him? We got about 3 more
Yeah,
minutes
you're
for
next.
him. So y'all can write down your comments that you saw.
So I connect, what was that? I think that was,
Oh.
I thought it was my iPad. I connected to the AirPlay. Then I turn on the TV, right?
I don't
Is
know.
this, what room is this?
205.
Okay, it says it's connected. I don't know how to do it with the computer though.
That, I don't know.
Do you know, Amy?
I'm sorry, what?
The Apple TV,
What about it?
how do I connect to it, do you know?
No, but if you don't know, Mark said, just come get me if she's not sure. So let me go get Mark. Dr. Riggs.
Okay.
Now, what I wanna know is if you overtake your iPad.
Overtake my iPad?
Uh-huh.
You wanna overtake my iPad?
Well, I've heard some people say that sometimes during the presentation, people can do that.
And then they'll like change it?
Well, instead of projecting from you, it does from me.
Oh. Hi. Okay, I connected to AirPlay, and then
Uh-huh,
I hit that.
uh-huh. I turned mirroring on.
Turn what on?
Mirroring,
Okay.
and you gotta tell it what the input is. You're still on the computer.
Oh, okay.
So you gotta do the laptop? Is that what's gonna pick up at?
Campus TV
Oh.
is the switch up here.
So you're underneath settings, right?
Mm-hmm. Then you have to connect to AirPlay.
So where am I going for that?
Uh,
Thank you.
Where do I go for that? Underneath
Under Wi-Fi? Yeah. Thank you, doctor.
You bet.
Oh, I need